All right, let's take a look at how we name ethers, and it depends on the size of the molecule. When we've got a small molecule or small ethers, they get the name of blank blank ether, right? Similar to our alkynes or our acetylenes. So for example, if we have this ether on one side, we have a methyl. On the other side, we have an ethyl. This would be methyl, ethyl. And then, of course, in the middle, ether, right? When you have two of the same thing on either side, so in this case, we have two ethyls on either side, we call this diethyl ether. We can have, of course, our other kind of more common functional names. So on the left side here, we have an isopropyl group. On the right side here, we have a tert-butyl group. So this one would be known as tert-butyl isopropyl ether. In terms of what comes first, it goes by alphabetical order based on the base name, right? So B goes before P, so it's tert-butyl isopropyl. You don't need to know this too much for this course because I only ask from name to structure, not structure to name. But if you want to be a pro on IUPAC, there are a lot of little oddities. Let's take a look at another interesting ether and another interesting nomenclature. So on this side, we have a benzene ring. And then on this side, we have a methyl, then a benzene ring, right? So we've got that on that side, and then this on this side, right? They actually get different names, right? So in the purple here, we have benzyl. And then on the left side, we have phenyl ether, right? So when you've got this little extra methyl, that's a benzyl substituent. When there's no extra methyl, it's a phenyl substituent. You can think about benzyl because of the benzylic position that this one has that the other one does not have. If you have larger molecules, then your ether is only a small part of the molecule. And so instead of being kind of the main component, it's just a substituent. So we're going to name it as though it's a substituent. And in this case, it gets the name alkoxy. And really just the oxy, right? Depends what else it's attached to. So let's take a look at some examples. Right, so over here we have phenol. So that's the base name, right? That's the large part of the molecule. And then we have this small ether. In this case, it's got a methyl group over here. So this is methoxy. And then, of course, we want to identify its location. The OH gets 1, 2, 3. So this is 3-methoxy phenol. Again, the bigger the molecule, the more you name the ether as a substituent. Put an alkene over here, and then an isopropyl over here, right? So, for example, we've got a cyclohexene right there. So we want to call that cyclohexene. And then we've got this isopropyl with the ether. So we call that isoproxy. And then, of course, we want to identify it, number it. You want to start with the number 1 with the alkene, and you want your alkene to go across carbons number 1 and 2. So 1, 2, 3, 4, 4 isopropoxy cyclohexene. Hexene. My bad. And then there's one more important ether that I want you to just kind of memorize the name of. This is THF. It's a very common solvent. We use it in lab. It's used in a lot of reactions. THF stands for tetrahydrofuran. Furan is basically the same thing, just with these 2 double bonds, right? So the tetra hydro means that we've added 4 H's to this to saturate this and make it more of an alkane. But there's naming for the ethers.